Assalamualaikum and very good almost midnight. So today I'm going to explain on how to do the question 1 for the tutorial 3 fluid. As we can see, the diagram is being given and there is point A and point B. Both points are given the diameter for each of the point A and point B. Another information that is being given is the velocity at A and the pressure at A and the head loss. So the question is need us to find the pressure at B. So as usual, by using the Bernoulli equation, PA over gamma plus VS square over 2G plus ZA plus hash pump equal to PB over gamma plus VB square over 2G plus ZB plus hash turbine plus head loss. So as usual, we analyze what are the things that we can cancel out, which is the ZA, because the point that we start is at A, so there is no height is occur. Inside the diagram there is no power pump, so we can cancel out hash pump and equal to PB is the one that we need to find. ZB over 2G plus ZB plus there is no turbine that is inside 2, so we can cancel out. So into the next equation, we fill up all the numbers that is being given, which is the PA 414 kilopascal into it. The gamma for water is 9.81. The plus the velocity, the volume, sorry, is 3.05 over 2 gravity 9.81 equal to PB, the one that we need to find, over 9.81 plus 12.2. Where we get this amount, even though it is not being given inside here, we can use the continuity equation. A1 times V1 equal to A2 V2. So the one that we need to find is V2 or VB is the same. It's the one that we need to find. So as usual, the mathematical, we left the V2 and we bring the A2 to the other side, which become A1 over A2 times V1. The A1 is 0.1 at the point A. The A2 is at 0.05. Why it being powered times by 2 at the top here? It is when the, what we call that, the pi meets the pi being cancelled out, so we can just take the amount and power of 2 of it and times by 3.05, which is being given here, and we get the number is 12.2. Put it inside as usual. So ZB is the one that from point A to point B, which is 9 meter, and the head loss, it is being given 7.62. By inserting the numbers in the calculator, we get the 255.61 kilopascal. That's it for the question 1. Okay, now we move to question 2. This is the diagram that is being given. There's pressure gauge at the top of it, and the water level 2.4 meter, and the nozzle has its diameter, which is 0.005 meter. The pressure gauge is being given the value, which is 140 kilopascal, and the head loss also is equal to 2 meter. The question wants us to find the volume flow rate, V dot. So as usual, the Bernoulli equation, P1 over gamma plus B1 square over 2G plus Z1 plus H power unit equal to P2 over gamma plus B2 over 2G plus Z2 plus H turbine plus head loss. From the diagram, we find out what are the things that we can cancel out. The first thing is the velocity, the V1. Why? Compared to the previous question number 1 on the diagram, the water is flowing from the top to the bottom, from the point A to the point B. As for this diagram, it's in the close, it's like a close in a box like that, which is there's a gap which filled by A, and there's a pressure in it. So there is no water that flowing from the top. It's like we can use like a lake, like that, very calm on the top. There is nothing flowing there's nothing that flowing, but there is something that flow on the bottom part, which is 0.005 meter on the nozzle with the size of 0.005 meter. And the one that we need to cancel out is a H power unit, and because of the water is going through the atmosphere, so the P2 can cancel out also the turbine. Okay, after we cancel out, and we bring out all the equation that is available, so becoming the P1 over gamma plus 2.4 equal to V2 square over 2G plus head loss. Adding in the value for the P1 is 140 kilopascal over gamma water 9.81. So the thing that we didn't know is the velocity, the V2. So because we have one unknown, we bring out the 9.81, and the value of 2, the head loss, to the other part. So we can left out one unknown here by inserting it into the calculator. We get the value of 2.287.848. Bring out the power of 2 square to the part, become square root, and we get 16.96. That is for the V2. We haven't finished it yet because the question want us to find the volume flow rate, which is the V dot, and the equation for the V dot is V dot equal to AV square. The equation, the A is the area for the nozzle, so the diameter is 0.005, so the pi 0.005 to the power of 2 pi r square pi d square, over 4 times the V2, which is 16.966. So we get the answer is 3.3 times 10 to the power of -4. So that's it for the volume flow rate for question 2. Okay, now we move to the question number 3. This question number 3 a little bit hard for me to digest. Took me a while to understand the question, but however, with the help of few of the friends, we are discussing how to do this. So yeah, this is the outcome. In the question, it want us to find the head loss, and the water flowing is 0.06 meter cube per second, which is a V dot. The diagram that is being given, only the point 1 and point 2 is the one that I adding up, where I want to know which place that I'm going to start the point 1, and the point 2 is where the things is being ended up. Okay, by using the Bernoulli equation, v1 over gamma plus v1 square over 2g plus z1 plus hash pump equal to p2 over gamma plus v2 square over 2g z2 plus hash turbine plus head loss. Alright, okay, as usual, from the diagram we can analyze about other things that we can cancel out. Obviously the z1, because it's the datum line, the way where everything is being started, and also the hash pump, because there is no pump. The p2 the hash turbine, because there is no turbine. So from the equation we combine it up, p1 minus p2 gamma equal to v2 square minus v1 square over 2g plus z2 plus head loss. Because we don't know what is the p1 and the p2, by using the manometer equation, p1 minus p water equal to p, no, I'm sorry, this one is actually the p mercury, my mistake, sorry. So the one that have inside here is the p mercury. We move up maintain the p mercury, we move up the p mercury to the other side and moving in the p2 inside, and we get the p1 minus p2 equal to p mercury. The equation for the pressure is rho g hash. So the rho is we have the SG 13.6. So the equation for this one is the SG is equal to rho substance over rho water. So rho water is 1000. The SG is being given, and we can get the raw substance. From here we get the 13600 put inside the row. The gravity is 9.81, the height is 0.35, and we get the 46695.6. okay, so the pressure, now we have the pressure difference, P1 minus P2, or known as the pressure difference. Okay, so this one is we can put directly into the Bernoulli equation. Same goes to the V. We don't know what is the V, but the question is giving us the volume flow rate, V dot. So from the V dot, with the equation of the V dot, we get V dot equal to AV. The one that we want to find is the V, and the things that we can find is the area and the V dot that is being given. So we get the equation of V equal to V dot over A. The V1 is at here, so we change the centimeter into meter as usual. We get 0.006 over 0.005 square over pi over 4 square, 0.05 square pi over 4, like that lah. And we get the answer is 3.056 meter per second. Same goes to the V2. Take this into here. For sure the V1 have higher amount than the V2 because we can look at the diameter. Okay, and put it inside the gravity 9.81 plus 1.2 meter. Where we get the 1.2 meter is from here to here. And the head loss is the one we want to find. By putting all the amount, the value inside the calculator, we get the 339.246 meter for the head loss. Okay, that's all.